Hey everybody, this video is going to talk about determining the end behavior of a graph of a polynomial function. But before we talk about that, we need to have a little bit of background information. So let's go ahead and back up a little bit, and then we'll get back to this. First, let's talk about notation for infinite behavior of y equals f of x. So if we have x arrow pointing to infinity, we say x approaches infinity. So what that means is our x, or our domain, our inputs, are becoming infinitely large in the positive direction, right? They're just going towards infinity. X arrow negative infinity is x approaches negative infinity, and similarly x becomes infinitely large in the negative direction. So we're going towards the negative infinity in the x direction. F of x approaches infinity, or f of x arrow infinity, is the y value, or our outputs become large, so they go up. And f of x approaches negative infinity is the y value becomes infinitely large in the negative direction. So let's talk about the leading term test. So if we consider the polynomial function f of x equals a sub n x to the n plus a sub n minus 1 x to n minus 1 plus, so what is this? That's a lot of notation. This is a function, a polynomial function, where we have coefficients or numbers in front of our x's, and this n value is the degree of the highest x that we have. So let's do a little bit of an example here. So if we had g of x equals 2x cubed minus 2x squared plus 1. Okay. These values here, these 2's, are these numbers, these a's, okay, in front of our x numbers. And this a sub 0 is the 1. And then our degree, or this n, is the number in front of the highest degree of the polynomial that we have. So something to take note is as x approaches infinity or negative infinity, this first term, because it's the highest degree, kind of takes over the function, and it's going to start looking like the function as if we didn't have any extra terms on it. So let's say our degree is odd, because we have a degree 3 here, right? Our degree is 3. Our a sub n x to the n in this case is 3x, oh sorry, not 3, is 2x cubed. So our degree is odd, and our a sub n, which is the 2 in front of the x cubed, is positive. So since n is odd and a sub n is positive, as x goes to negative infinity, so as we approach negative infinity, we can see that our outputs are going down. So we're going down to the left, and then as x goes to positive infinity, we're going up to the right. But if a sub n was negative, remember that's an x-axis rotate, or an x-axis flip, and so we'd end up with kind of the opposite end behavior. If n is even, if a sub n is positive, or if our coefficient, it's called the leading coefficient, is positive, then I'm going to have something that opens up. And if you think about a parabola, right? A parabola opens up. And all this polynomial is like a parabola with stuff in the middle, and then it keeps going up. Okay? And then If a sub n is negative, it's like it's going to go down. So end behavior is down, left, down, right. All right. Now, let's go ahead and look at these problems. Choose the end behavior of the graph of each polynomial. So this is negative x to the fifth minus 4x to the fourth minus 5x cubed minus 3. The leading term is negative x to the fifth. So we have an odd degree, and our leading coefficient, the number in front of our highest degree value, x value, is odd. So we're going to have end behavior up left, down right. So it rises as we go to the left and then falls to the right because it's going to have this general form. So as we go off to the left, it's rising, and we go off to the right, it's falling. So it rises to the left and falls to the right. For the next one, it is the leading term is negative x to the fourth. So our a sub n is negative, but we have an even degree. So that means we're going to look something like this. So as we go off to the left, it falls, and we go off to the right, it falls. So it falls to both the left and right. Now what about this? The 5x squared is not the leading coefficient, or the leading term, because this function actually, we need to multiply it all out. So I'm just going to multiply what I know is going to be the biggest, give me the biggest degree. So 3 times x is 3x squared, and that is multiplied by 5x squared eventually. So I'm going to get 15x to the fourth. That's my leading term. So that's a positive even, so it's going to be like this. So as I go off to the left, it's going to rise, and if I go off to the right, it's going to rise. So for this one, it rises for both. That's determining the end behavior of the graph of a polynomial function.